Hi, my name is Arkadiy Kukarkin from the Internet Archive, and I'm here to tell you a story about the Internet Archive and Filecoin. So, first, a little bit of probably boring, redundant context. I'm sure you all know what the archive is, but we're one of the largest, if not the largest, depending on the metrics used, digital libraries in the world. We're probably best known for the Wayback Machine, which has been archiving the visible internet since 1996. But we also have a huge number of other collections, including live music archives, film scans, books, and a variety of other media. Actually, also games emulated in browser. If you ever want to play like an Atari game, you can do it right on our site. Oops, that shouldn't exit. Okay. So the total data set is north of 100 PIB. The exact figure is a little bit proprietary, but at least 20 PIBs of these are fully clear text, totally unencumbered. Then there is kind of a middle ground where there is some amount of gated access depending on the legal context, and then there is a certain amount of black hole material that is purely research oriented. We also have been experiencing explosive growth in user signups. This is actually an old graph, but it continues to go up and to the right, which is very good, but also places a significant amount of strain on our systems. We are also not just internet weirdos, we are a real library. We're a member of all of these wonderful library associations. Okay, so I promise this is the only slide with so many bullet points. So the particular quirks and requirements of our organization when it comes to most things, but particularly with the Filecoin project, is first of all, just to get this out of the way, not your keys, not your data. We need to own the wallet that is making the deals. We need to have control over the pipeline. That's just kind of a non-negotiable ground. We also have a 100+ year mission and a budget that is allocated accordingly, which, to put it another way, we're quite cheap. We use standardized and fungible machines, which are on-prem. We do not use any other vendors. We drive the cost down below the point where people can find them believable, despite operating in the same apparent space. This also means that we scale through parallelism. We do not scale by allocating large instances on Amazon or buying a top-tier Supermicro chassis. We generally throw more machines at the problem because that keeps the IT costs down, and we have a very small IT staff. We're nearly always operating near capacity for the same reasons, and as you could see in the previous slides, we've been growing really rapidly. The other thing that is very difficult to communicate well to the Filecoin community is that the network that we use for interacting with service providers is actually shared with what we call patrons or users. So despite having multiple 200 gigabit links and good interconnects, if you try to run a single TCP stream, you will never get anywhere near the what should be available bandwidth. And this goes through several layers from QoS to organic switch load to finally just the spinning disks where the data originates. We do a lot of compute in-house. The compute is done for things like video transcoding, book OCR, and so on. And this is actually the infrastructures that we end up using in support of data preparation. We also have a strong notion of a basic organizational unit of data, which we call an item. It's essentially a primary keyed directory that lives somewhere on a file system among hundreds of VMs that we call our data nodes. And I guess the latter is a Filecoin specific requirement, which is that we generally prefer fill plus or data cap driven deals because, again, budget. We can talk about it.
Used to. Not so sure now.
Actually, it might be moving in a different direction, but let's keep the questions to the end. And by the way, when I say on-prem, I mean like really on-prem. This is our headquarters, which is located in an old church building, and this is the main hall, and those machines are actually serving real requests. So yeah, it's real. Okay, so for our story time, a long time ago, in a land far away, we initially tried to use Lotus by running a light node, and actually at one point, yes, even paying some fill for some deals. Without going into too much detail, because I think we probably know how that went, it didn't work. Getting into more functional chapters, the next tool we tried to use was SGRE, which was in the first half of last year. We ran an on-prem node as per the requirements that I listed. And we actually liked a lot of things about it. The deal management, theoretically the lifecycle management, actually really took a lot of labor off my hands. The notion of an abstraction between inputs and a managed state within Filecoin really felt very attractive. Unfortunately, it had issues as well, particularly in protocol transfers. Were working not much better than they were with Lotus. So that's kind of a big non-starter. We had like 15% success rate or something like that. Or as we'll see with many other tools, it was meant for really a gigantic box with a really fast pipe and direct file system access to stuff. And even though it had workers, those workers would just be more big boxes. So again, not how we do things. The one thing that we did take away from this that was carried through a lot of later work is that if you recall, we organize data into directories, which we call items, and that have a less than 256 character alphanumeric name. SGRE's API was an HTTP post API, which, as you know, multi-part uploads are very tricky. Directory uploads are very tricky. So we actually developed, in conjunction with the SGRE team, we developed a way to upload car files where we would generate them on the data nodes from the directories, and then transmit those to SGRE. There was actually a different function that accomplished the same goal, but it would require adding to an intermediary IPFS node, which is also a non-starter. So a bit later that year, we've entered the next chapter, and this was a remarkable one because we actually could make deals in a somewhat predictable and consistent way. So, wow, amazing. We really liked Boost's small stateless client and the fact that it doesn't actually need to have file system access to the files that it's making the deals about. So this strong decoupling, very lightweight, stateless. Really love this. However, the tool came with its own issues. Online deals, which is sort of the default mode, tended to overwhelm SPs. There was no way to provide back pressure or other flow control between us and the storage providers. The only way that you could diagnose this process was by analyzing plain text errors returned in the logs. And I was surprised by the range of conditions because this is essentially totally a free-form text field. So people would say, hey, I've gone on vacation, I'm visiting my in-laws, the SP is off, things of that nature. So it's, as you can imagine, that's a little bit difficult to categorize or programmatically respond to. The converse mode, which is offline deals, where data is transferred out of band to SPs, be it by sneakernet or bulk download, did not have those problems because SPs were in fact in control over their own onboarding rates. However, in reality, this often means somebody in Singapore messaging me on Telegram at 2 a.m. somebody's time, and us sending back and forth CSVs of comps and things of that nature, which is not a very scalable solution, as you can imagine. In particular, the offline deal flow didn't work great for us because we are continuously acquiring new material, both through the operation of the Wayback Machine, our scanning operations, user submissions, and so on. It's not, at no point do we really have a complete data set of any kind, which is what a lot of SPs expect in this context. Oh, and for an extra bonus, after about 6 months of using this to make deals, I was told that the Boost client was never meant for production use and was a testing tool only. So I'd love to hear more. As a quick aside, one of the tools that we looked at and decided not to pursue in our production environment at that time was Singularity. There are many great ideas, and I'm looking forward to the Singularity 2 session, which I think is tomorrow. The reason that we couldn't really use it is, again, it's quite stateful. It requires a Mongo that maintains state records from, I believe there are 3 components in Singularity. And it also does assume that the files are on a reasonably fast either local or network mount, which is absolutely not the case for us. If you want to read our files, you use HTTP GET. If you would like to write files, you use rsync. It's very, very primitive, but it actually works quite well. Nonetheless, we're open to revisit, especially the second release. Sorry. So this slide was supposed to be titled something like current chapter, and until 2 weeks ago, that was the case. But we'll get to that in a moment. After some months of frustration with the Boost workflow, which essentially it crept along, but it did not achieve anywhere near the throughput that we needed, because essentially we had to try to guess an average SP's average onboarding capacity and overshoot that by maybe 10 or 15%. So it was just really regression to the mean all around, and not able to scale. Starting about in late April or May of this year, we started working with a tool called Spade, which in my mind has generally balanced the upsides of offline and online flows that I discussed previously. And the way that it's been working has been very, very straightforward. So we prepare car files as before. So our existing compute, now using slightly updated but essentially equivalent tools, Analyze, creates the car files. We run a daily aggregate job that creates a CSV, which you can see at the bottom here, an example, headers and an example row of. And then the Spade service ingests these CSVs and makes them available to KYC'd set of SPs, who then, at their own leisure and according to their own needs and using their own automation, pull these in, push a deal proposal to our automated signer, which is just running on a Nomad cluster. And from my perspective, it works in a completely unattended fashion. I'm going to come back to the last line in a moment. Okay, so this is the graph that represents both the car file production and the actual onboarding rates. Ignore the fact that there's an impossible crossing on the left side. This is kind of an accounting artifact. But essentially, as you can see, up until April, we had some occasional bursty onboarding, mostly in the previous fall. I think that was a large offline deal batch, but kind of a sad picture for the most part. So starting in late April, we essentially stopped trying to run boost deals and very optimistically turned on the car production pipeline with certain onboarding targets. And as you can see, we've actually had some very good weeks. And the final for this chapter target of about 1.5 pibs on chain was reached. However, we also overproduced the car files significantly because the production and onboarding rates weren't linked. So there's another step where we sort of needed back pressure. And then, so this fall or this September, as we have been kind of patiently waiting for the onboarding to catch up and essentially consume this gap here, an unrelated storage-related emergency. Capacity planning is hard, especially when you're trying to have razor-thin margins of error, caused us to really need to deallocate a lot of that data, or as much of that data as possible. The problem is that in order to make these metrics look nice, make that blue graph of unique on-chain bytes go up and to the right, we really optimized for, again, for onboarding unique pieces as opposed to getting solid replication, where our spade policy was targeting 4x replication, which is actually lower than was at that time recommended for durability, but we have not been treating this data set as irreplaceable, and we retain two on-site copies. So since none of the pieces actually reached that replication, we couldn't delete them because they were still considered available for other SPs to replicate. And finally, we also have, again, this 1 pib plus set of things that have never been replicated at all. So as an emergency measure, we've had to coordinate with the Spade team, remove those items entirely from the Spade system, and also garbage collect them on our end. So that leaves us in a difficult position because we have a somewhat zombie set of 1.5 pibs on chain that are actually not replicated. And we also do not have the SP pickup that we're looking, that would be necessary to close that gap in a reasonable amount of time. So that's on the one hand. On the other hand, this incident has demonstrated that the retention of car files, especially in this unbounded fashion, is not sustainable for us and is in fact counterproductive because the ultimate goal is to shift storage capacity away from our systems and onto Filecoin SPs, which this is quite counterproductive for. So we're quite interested in alternative solutions. So streaming car generation is one area that could help. The two challenges there are deterministic structure and deterministic and stable comp p values. And the kind of the converse to that is that our SPs have been using custom ARIA2C tooling to download things with 5 to 8x parallelism, which, as I said in the introduction, tends to be the best way to achieve performant downloads from our network. So making that happen, streaming across a DAG, is challenging because range headers don't necessarily map to where you want them to. And lastly, maybe I'm hearing rumors that we can just bypass the car altogether, but I guess we'll hear more about that during the coming days. Finally, I kind of wanted to put the GIF in here, but I'm just going to make the reference that I think many of you will understand, and then say SPs, 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 SPs. We throughout this process, we have struggled so dearly to source SPs in sufficient quantity, quality, and responsiveness to actually accommodate our needs. It's the ones that we worked with I'm eternally grateful to, but there's churn, there are unpredictable circumstances. There's just not enough within our data, within our working set, and we are, I think, amongst Filecoin customers, a high reputation, high social interest, highly engaging entity. So if we're in this boat, then I'm not sure where others will end up. And I'm just going to leave retrievals there. We have 10 hours of talking about that. So just going to say it's very important for us.
The question, are you currently, and you probably said this, are you currently paying anything at all to SPs?
So we're in discussions with the foundation about either fiat or fill payments. There are a lot of questions about what precedent that will set. So we're not necessarily looking to pull the trigger on that thoughtlessly.
A good precedent. But I mean, if you ask the SPs what would change the behavior of what you were describing as a bad SLA or commitment, in my mind, it's like, yeah, if you start paying them, we can make a difference.
We're in the process of getting kind of a more formal survey of answers to that question. I've heard different things. I've heard a lot of uncertainty about the future of the network as a whole as a significant factor that might not be outweighed by competitive rate payments. Yes.
How many SPs are you working with?
So at peak we had maybe 15. Currently it's actually trickled down to a much lower number. I think we only have like maybe 3 or 4 actively. Yeah, 4.
15 at what kind of daily throughput?
So at peak we were onboarding like maybe 20-25 TIB daily.
Okay. We actively onboard over 100 TIB a day from multiple customers. More than happy to have that conversation.
Great, love it. Any?
Last slide there.
Oh yeah. Oh the last slide is a thank you.
If we just go back to the different, or this one.
This.
Yes, all the different chapters.
Yeah.
Which one for you was the ideal way of onboarding data? Is it like boost online that work? Like when you send something, it's release it, which be the best one, or have you seen any benefit in other approaches?
So we really like Spade because I don't want to have my operations coupled to SP's operations as much as possible. I want there to be a buffer. I want our data preparation rate to be based on our systems and our needs, and the SP, especially any fluctuations in SP capacity to be absorbed by a buffer. That is just not my problem.
But if you have 100 SP instead of 15, there are always someone available to take your data.
That sounds great.
Maybe I have a related question.
Yep.
What requirements do you have for an SP to be permissioned into your deal taking?
We're relatively relaxed with that. We are not able to work with mainland China SPs because we're blocked by the firewall. But outside of, and there are also some policy concerns with, for example, if we're storing like U.S. government documents and things like that. But overall, we're pretty relaxed. We do want, unsealed copies, fast retrieval, and bit swap and HTTP retrieval. But yeah, we're pretty flexible.
So you want each SP to have an unsealed copy, a sealed and an unsealed?
I think at the moment that's the only way that retrieval will really work.
Okay. There could be another reason that it's hard to
Any
find.
other recommendations on like improvements
So I will make one general across the board comment, which is that I dearly implore all testing to happen not just on Amazon networks and diverse network environments. I think I see so many slides that are talking about latency between Amazon regions and things like that, and we're just in a completely different world. So a lot of the assumptions that hold on their interconnect is just don't hold for us. I would really like to see the Lotus code base get a severe, how to put it, not a refactoring exactly, but I'll give you an example. There is a sealing pathway that is, if you're not using any workers, which almost everyone is using workers, so this was not seen for some time. But the sealing pathway, the add piece, just doesn't work at all. And this was not discovered for several weeks. So I think there is quite a lot of Lotus functionality that needs a review and possibly culling. Deep.
From working with you guys in the last couple of years, one of the things that stood out is the networking setup is pretty interesting, and the networking constraints are also interesting. You're one of the first clients that I've seen, whether it's because you use your custom networking setup or because you've got preferential agreements with ISPs and stuff, where you actually rate limit, like you actually hit that point. Like we're not seeing like a lot of people hit that point yet because either they're afraid to spend the money or because they've just like over-provisioned hardware. But for you, you actually do hit that point, and I'm curious how the current architecture that you see with using the Filecoin has actually resulted in you needing to change your network infrastructure, if at all, or rethink the way you set it up as a data owner at the Internet Archive.
So I think if we get further down this road and I can make the case for making capital investments in dedicated infrastructure specifically for interfacing with Filecoin, I think there could be a conversation there. At the moment, this is one project amongst many and many at the archive, and they all use shared fabric, which is also being used by our millions of daily users. So you just have to kind of learn to live and hunt your lunch in that environment. Yes.
Suppose you download 1 petabyte from this news.
Mm-hmm.
And try to do this in, like, say, 2 weeks. Where are you interconnected on the planet? Are you in Amsterdam connected on the M6? Or?
I can give you more details offline where we have. Let me give that to you aside from this. Yes. Oh yes, I was reacting to your hand.
I was going to say thank you. I think we're at time. This has been great.
Great. Thank you.